Okay, so in the next slide, we'll be looking at what we call the pressure enthalpy diagram or Mollier diagram, which is a bell-shaped curve representing the pressure, temperature, and enthalpy relationship of water at its different states. Naturally, there's also a diagram for different types of fluids, but of course, for the steam table, ito yung kailangan nating intindihin. Alright, so for this Mollier diagram, so we have on the x-axis the specific enthalpy of water in kilojoules per kilogram and the pressure in megapascals. So simply put, this is telling us na depende sa pressure and temperature combination ng water ay kung doon nakadepend kung ano yung kanyang state. Okay? So, and that is dependent on well those things, and that would also tell us about its enthalpy or how much energy there is. So if you look at this curve, so pag ganun siya, and then makita niyo dito may CP or parang critical point which separates the left side of the curve and the right side of the curve. So, makita niyo rin may mga label siya kung anong klaseng phase of water ang meron siya. Alright? So, this region is called the subcooled liquid. Simply put, it is liquid and below the boiling point of your water. The saturated liquid curve, on the other hand, represents all points, combinations ng pressure and temperature at which the water is at its pinaka-boiling point. Remember, as we know, the boiling point of water is actually dependent on the atmospheric pressure niya, di ba? On the other hand, the right side of the curve is the point at which all of the water has just turned into gas but is at the same temperature as the liquid. So kumbaga kung nasa normal atmospheric pressure tayo, kung ang water mo ay nasa 100 degrees Celsius, so saan ba? Ito ata yun. And then all the way up until the point at which it turns into steam at 100 degrees Celsius. So, yan yung point na yon from here to here. Okay. Superheated vapor or superheated steam is any point at which the water has turned into steam and its temperature is above the boiling point at that pressure. Meanwhile, the mixture of liquid and vapors, ito naman yung tinatawag natin na yun, no, yung the water is at its boiling point pero hindi pa siya totally nagiging steam. Sige, babalikan ko muna yung nakaraang diagram para mas maintindihan natin. Okay, so in reference to the pressure enthalpy diagram, so itong point na ito, up until before it freezes, yan yung region na tinatawag nating subcooled liquid siya. And then this point of inflection right here represents a point in the saturated liquid curve. And then any point along this line is a point inside the vapor liquid curve. So vapor liquid mixture at this point yung water, parang as you at this point 100% vapor pa siya at the boiling point. And then as you heat up your water some more, dumadami yung amount ng steam at the boiling point until it reaches this point saturated vapor curve wherein your steam is at 100 degrees Celsius and there is no more liquid left, puro vapor na, water vapor. Then itong point naman ito is yung superheated region. This simply means that again you have water above, you have steam which is above the boiling point. So just to further illustrate that again, so first of all, this applies for temperatures above the freezing point. And the water can exist in the following forms. Akala natin liquid at gas lang. Apparently, may very specific na tawag pala sa kanila. So again, it's called saturated liquid if liquid water is in equilibrium with its vapor. Okay, so ibig sabihin lang po nito ay pakulo na siya. The point at which ready nang tumalon yung individual water molecules from the liquid pool to the atmosphere. But what if the pressure above the liquid becomes greater than the vapor pressure? Okay, so pag nangyari po yun ay meron tayong tinatawag na drum roll please. Tugtugtug. Okay, vapor liquid mixtures. Ang ibig sabihin lang po noon ay nagsisimula ng tumalon yung iyong liquid into vapor form. So typically we call this steam with blank quality, blank referring to a certain percentage greater than 0 but less than 100. So when nabasa nyo sa isang problem na sinabing may steam ka with something quality, then it only pertains to how much percent saturated vapor there is in the mixture. So for example, if you have steam with 1% quality, halimbawa, then that simply means you have a vapor-liquid mixture wherein 1% of the mixture is vapor and 99% is saturated liquid. Okay? Alright, so kapag naman umabot sa point na tuluyan ng naging vapor lahat ng liquid mo, tinatawag na natin itong saturated vapor or also known as saturated steam. And it is simply when all of the water vapor is at the boiling temperature ng fluid mo. And when this happens, so you could either lower the temperature at constant pressure, which causes the condensation or partial to full condensation of the liquid, or further increase the temperature leading to the superheated steam region. So before we continue, ayan, subukan nyo namang isipin ano ang average consumption ng refrigerator. So bakit average ang tinatanong ko? As we know, the most refrigerators have a compressor that turns on and off yung mga mas lumang design. For the newer designs, they have a compressor with a variable speed adjustment. Pero generally, kasi meron niyang minimum and maximum output and nagsa-self-regulate siya. Depende sa set na temperature mo. Much in the same way that air conditioners do. So we want to guess, on the average, how much does my refrigerator, let's say, consume in watts? Okay, and the answer to that is around 60 to 90 watts, yung mga ganyang size na refrigerator. So typically kasi when the compressor is on, it can consume upwards of 200 watts. But at the same time, kapag off siya, obviously it consumes close to 0, no? So, dahil yung ibang lumang ref nag-on off lang, or yung iba naman, they run at let's say half the rated capacity. So, kaya may kinukuha natin yung average na let's say over a day. Kasi yun naman ang mahalagang bottom line sa atin. How much are we spending for our electricity cost per day on this appliance para ma-multiply mo in a month what percentage of my electricity bill ay dahil sa refrigerator na ito. Typically, they consume much less than air conditioners despite refrigerators being open for 24 hours. Kasi sobrang liit naman ng space na kanilang kailangan palamigin. No, hindi nga kasya yung ikaw sa ref, di ba? Unless sobrang laki ng ref nyo or walk-in freezer yan. Pero yung kwarto mo can easily fit maybe 10, 20 or 30 refrigerators. That makes sense, di ba? So anyway, back to the topic. At any temperature above the freezing point, sabi nga natin kanina, if you have a vapor-liquid mixture, if you added heat to your vapor-liquid mixture, mangyayari lang sa kanya is hindi mag-change yung temperature and pressure niya until all of the saturated liquid is converted to saturated vapor. If you can see the blue on white graph a few slides back, di ba? Kaya nga meron tayo doon na vertical line indicating no change in temperature. On the other hand, if you subtract heat from it, hindi rin mag-change yung temperature ng vapor-liquid mixture mo until the saturated vapor is converted into liquid. So, self-explanatory naman yan dun sa graph natin kanina. Alright, so hindi ko alam kung sino yung nakaisip ng pangalan na ito na parang pangalan ng isang superhero. But at any temperature above the freezing point, once you've had saturated vapor tapos nag-apply ka pa ng heat to your saturated vapor, it will now become superheated vapor or superheated steam. Okay? And of course, this simply means that superheated steam has more energy that it can use to heat your food than your saturated steam or vapor-liquid mixture. And the difference between the boiling point of the liquid and the temperature of the steam is what we call degrees superheat. So for example, if the boiling point of water is at 100 degrees Celsius for a certain pressure, and then you have superheated steam at 120 degrees Celsius, then you can say that there is 20 degrees of superheat. Okay, so if we have superheated steam, ano kayang pwedeng mangyari if we have superheated steam and then added more heat at constant pressure? So, ang mangyayari po dito ay since constant yung pressure niya, the temperature would increase in proportion to the increase in volume. Paano naman po if it's a constant volume situation, like let's say you have a pressure canner or pressure cooker, then if you add more heat to superheated steam, hindi magi-increase yung volume niya, so magi-increase yung temperature and pressure niya proportionately. So if you still remember your PV-nRT equation, yun lang naman din yun, no? And what if we remove heat from superheated steam? Kasi diba, if you have superheated steam coming into contact with the metal walls of a steam-jacketed kettle, then it will obviously transfer heat because it has a higher temperature. So, heat will be removed from the superheated steam. Temperature will lower until such point na maging vapor-liquid mixture siya. So, from superheated steam, magiging saturated steam or saturated vapor. And then from that point onwards, constant temperature lang siya, magko-condense siya until maging saturated liquid. And once it becomes saturated liquid, doon lang uli bababa yung temperature niya until mag-equal yung temperature ng liquid mo tsaka nung whatever it's in contact with, whether siya yung metal na jacket ng steam jacketed kettle or yung food mismo, like kung nagsa-steam ka ng siomai, di ba? And that is the reason why steam has superior heating properties. No? If, kung mapapansin nyo, kung ikaw nasubukan mo ng mapaso ng mainit na tubig, mas masakit yon kung napaso ka ng same amount of steam. Diba? Kasi instantaneous yung pag-transfer ng heat ng steam na pag yan na nag-connect sa balat mo, yung enthalpy drop niya from superheated steam unto becoming liquid at the same temperature as your skin, instantaneously, yung lahat ng energy na yon ay na-transfer sa'yo at masakit yun. Okay? So kung ikaw yung pagkain, luto ka agad, in short. And that's the reason why they conveniently use steam for the heating and cooling of food. Alright, so yung different forms of water that we've talked about so far ay prelude lang yan sa paggamit ng steam table. Because to be able to use a steam table, you need to know the different states of liquid, those 5 that we've discussed, and the concepts about enthalpy as well is needed for understanding. So ano nga ba itong steam tables na ito? Simply put, ito po ay mga tabulated value for the properties of steam, specifically saturated and superheated steam. The values included there are temperature, absolute pressure, and the properties of saturated liquid and vapor at different temperatures, as we'll see in the next slide. So this is an example of properties of saturated steam, or part of a steam table taken from Singh and Heldman 4th edition, 2009. So as you can see on the leftmost column, you have your temperature, which is obviously the temperature of the water or steam. Then you have here your vapor pressure, or the pressure at which the liquid will turn into vapor. Okay? So ito, self-explanatory. Ito naman ay enthalpy. So sabi nga natin, di ba, at the temperature reference point, the enthalpy or energy content of your water is considered to be 0. And then notice that as we increase the temperature of the liquid, by heating it, yung heat na na-absorb niya to increase its temperature, yun yung equal sa enthalpy niya. Okay, so take note that enthalpy is from state 1 to state 2. No? So, for example, if I were to heat 1 kilogram of liquid, no, from 0.01 degrees Celsius, no, galing siya sa ref, to 30 degrees Celsius, then the change in enthalpy would be the difference of this one and this one, which is 125.79 kilojoules of energy for 1 kilogram of water. So that's the total amount of heat I need to be absorbed by the water to increase its temperature to 30 degrees C. Pero kung makikita natin dito, for the same temperature, kung vapor siya, di hamak na sobrang mas malaki yung energy niya. No? So that is why we want to use the steam table. So essentially, when we're using steam tables, for example, yun nga, nag-boil ka ng, nag-heat ka ng water from 0 degrees to 30 degrees. You're just using the tabular enthalpy values to compute for the change in enthalpy, which could either mean yung energy required to bring it up to a certain temperature, or the energy that your steam could lose if it were to give up its energy to heat a food product. Yung entropy, for the most part, hindi naman natin pakikialaman yan sa food eng. Ayan, so pansin nyo, nagpalit ako ng damit. This is actually 2 days after the original recording. I have to correct something here kasi parang kulang pala yung record ko nung una. Anyway, when you have steam table, so itong exercises natin pwede nyong gawin. First is to find the enthalpy of saturated steam at 50, 100, and 120 degrees Celsius. So kung yung temperatures na yan ay nandun na mismo naka-indicate sa leftmost column, then you just have to find the enthalpy values HV there, no? And then to find the latent heats of vaporization at those respective temperatures, you just have to subtract the enthalpy of saturated liquid from the enthalpy of saturated steam at that temperature. Okay, kasi their difference is the latent heat by definition. Okay, so later on we'll be looking at interpolation of these steam tables. So that would be in the next part of this module.